In this video, I'll be working through the Mpumalanga Term 1 Mathematics exam for grade 10, and this is last year's paper. So this exam was written on the 24th of March last year. It was for a total of 50 marks and it was 1 hour long. Starting off with question 1. 1.1 says, indicate between which two consecutive integers the square root of 47 lies. Now, when we look at square root of 47, the fact that it is being square rooted means that we need to check between which two square numbers it lies. So here is a list of square numbers, and if we look for something close to 47, we notice that the closest number before 47 is going to be 36, and the closest number after 47 is 49. So this is how we need to write it. We're going to say the square root of 47, that lies between. So we're going to write this as square root of 47 lies between the square root of 36 and the square root of 49. So we've got the square root of 47 lies between square root of 36. If we have a look at this table, we know that it is 6 squared. So the square root of 36 is 6. And if you look at 49 on your table, that is 7 squared. So the square root of 49 is 7. So that is going to be your final answer. And say, for example, that you've got this, but you're not sure if it is correct, you're most welcome to do a check. So part of our check, I am going to take the square root of 47. I'm going to plug it in onto the calculator and get a decimal value of it. Now, the decimal value that I'm getting rounded off to 2 decimal places is 6.86. And you guys can clearly see that this value lies between 6 and 7. So that means that this answer for 1.1 is correct. Now for 1.2, they say write 0,13 recurring. So those dots above the 1 and 3 means that those values are recurring. What we actually have is 0.131313, and it continues in that manner. So they want you to write down 0.13 recurring as a fraction. Clearly show all your steps. Now, you guys, this is actually a grade 9 question. So this question has absolutely nothing to do with grade 10. And not sure if you guys remember the method from last year, but the first thing we do is we let x equal to that recurring decimal. So we're going to let x equal to 0.131313, and you have to show that ... afterwards to show that it does not end. Now, I'm going to refer to this as equation 1. In the next step, we're going to count how many numbers are repeated. So 1, 3 is repeated, meaning that there are 2 numbers that are repeated. So we're going to multiply this by a number that has 2 zeros. That number is going to be 100. So we're going to multiply the left-hand side by 100 to give us 100x. And we're going to multiply the right-hand side to give us 13.131313. And we'll refer to this as equation 2. The next step is for you to take equation 2 and minus equation 1. So we will have 100x minus x on the left-hand side. And on the right-hand side, we will have 13.131313 minus 0.131313. Now on the left-hand side, 100x minus x is going to give you 99x. And on the right-hand side, this step eliminates those numbers after the decimal. So you will be left with 13. All you have to do from here is make x the subject by dividing throughout by the coefficient. So we're going to be left with 13 over 99. And that should be your final answer. So for this kind of question, you can actually check if your value is correct. All you have to do is take 13 divided by 99, plug it into your calculator, and change it to the decimal form. And you will see that it does give you the 0.13 recurring. Let us now go on to 1.3, and for this question we are required to factorize. 1.3.1, we are given x squared minus 3x minus 10. And you guys remember that in grade 10, you have many different types of factorization. And your aim is to identify the format that each question is in. This x squared minus 3x minus 10 is a quadratic trinomial. So it is a quadratic trinomial. So for this type of question, here's what we do. We are going to look for factors of the last term. Now, factors of 10 would be 1 and 10, 2 and 5. And we actually have negative 10. So remember how this works is you are looking for factors of the last term. When you multiply them, they must give you the last term. And when you add them, they must give you the middle term. So there is no way that we can add 1 and 10 to get negative 3. So I'm going to go with 2 and 5, and I'm going to use this as a positive 2 and a negative 5. So to factorize, we are going to open up two brackets. We're going to fill in x, and one bracket is going to get plus 2 and the other bracket negative 5. Let us now have a look at 1.3.2. We are given 25x to the power 4 minus 4y to the power 8. And again, before you attempt this, you need to figure out and identify the format that it is in. Firstly, we notice that we have two terms. 25 is a square number. So is x to the power 4 because it's x squared times x squared. 4 is a square number, and y to the power 8 is also a square number. And we've got a minus in between. So this is definitely the difference of two squares. So here is what we have. And our method for factorizing difference of two squares is we open up two brackets. Now we are going to ask ourselves, what times itself is going to give us 25x squared? That is going to be 25x to the power 4. That is going to be 5x squared times 5x squared. And again, what times itself is going to give us 4y to the power 8? That is going to be 2y to the power 4 and 2y to the power 4. Now, you may be wondering, how exactly is it that y to the power 4 times y to the power 4 gives you y to the power 8? Remember that when you are multiplying bases that are the same, you are allowed to add the exponents. So this just comes from applying laws of exponents. And then with factorizing difference of two squares, one bracket gets a plus and the other bracket gets a minus. So that would be it. Now for 1.3.3, we are given 125x cubed plus 27. Firstly, you guys, 125 is a square number. Is a cubed number. X cubed is a cubed number, and 27 is a cubed number as well. However, we have a plus in between. So this is the sum of two cubes. The sum of two cubes. So to factorize sum of two cubes, we are going to open up two brackets. Bear in mind that the first bracket is a binomial and the second bracket is a trinomial. Now, to get the binomial, it is dependent on the question. So you guys are going to say cube root of 125, that is going to give you 5. The cube root of x cubed is x. The cube root of positive 27 is positive 3. So you get that first bracket, that binomial, by cube rooting the question. Now, to get the trinomial depends on the binomial. to get the first term, we are going to square this first term. So 5x times 5x would give you 25x squared. To get the middle term, you are going to multiply both terms together and change the sign. 5x times positive 3 would be positive 15x, but we are going to change the sign, so that is going to give us negative 15x. And to get the third term, we are going to square the second term. So positive 3 times positive 3 is positive 9. And that would be the answer to this question. Let us now have a look at 1.3.4. We are given 3x minus 6xy minus 2y plus 1. Now, the minute you guys notice that the question has 4 terms in it, that is definitely going to be factorizing by grouping. So 4 terms would be factorizing by grouping. So this is what we're given. And the first step would be to group these terms. But before I do that, I want to point out that it is important that when you group your terms, you group terms in pairs according to terms that have something in common with them or in common with each other. So we're going to group 2 terms and then another 2 terms. And if I look at the first 2 terms, 3x minus 6xy, I can group those together because they've got the 3 and the x that is in common with each other. I'm then going to put the plus in between, and negative 2y plus 1 does not have anything in common, but I'm just going to swap them around. I'm going to put the positive 1 first and the negative 2y. We'll see why just now. When we factorize in the first bracket, we notice that both terms contain 3 and they contain x. So let us pull out 3x as a common factor. In the first term, you're left with 1, and in the second term, you're left with negative 2y. Now, in the second bracket, there is nothing common, so it's going to stay as is. And you guys, this is exactly what you are looking for. At this point, you need both of your brackets to be exactly the same. If they're exactly the same, it means that you have done the right thing, you have factorized correctly. To finish off this question, those 2 brackets that are the same, you're going to write it out once, and whatever is in front of them goes in another bracket next to it. So in front of the first bracket, we've got 3x, and in front of the second bracket, we've got plus 1. So that is going to be our final answer. Going on to 1.4, it now says simplify fully. So 1.4.1 is based on products. Notice how we have a binomial being multiplied by a trinomial. So to do this, let us start off with this 2x. We're going to take that 2x and multiply it with all 3 terms from the trinomial. So we've got 2x times x squared, which is going to be x cubed. 2x times negative 2x is negative 4x squared. 2x times positive 3 is positive 6x. So we are done with multiplying that 2x out. We're now going to focus on the negative 5, and we're going to multiply this negative 5 with all 3 terms in the trinomial. So negative 5 times x squared is negative 5x squared. Negative 5 times negative 2x is positive 10x. And negative 5 times positive 3 is negative 15. Now we have to get the like terms. So notice how you've got 2x squared minus 4x squared. Actually, slight oversight, 2x times x squared is going to be 2x cubed. Okay, sorry about that. So there is no like term for that. Let's go on to the terms that have x squared in it. Negative 4x squared minus 5x squared is going to be negative 9x squared. Then we've got a 6x plus 10x, which is 16x. And the only constant that we have here is negative 15. Now, this cannot be further simplified, which means that is our final answer. In 1.4.2, in our numerator, we've got x squared minus x minus 2. Immediately, you guys notice that is a quadratic trinomial. And our denominator is basic, it is just x plus 1. So I want to start off by factorizing that numerator. Since it is a trinomial, we're going to open up two brackets. We know that the first term in each bracket is going to be x. We are now looking for factors of negative 2. So 2 is a prime number, but we are looking for factors that when we multiply them, they give us negative 2, and when we add them, we get negative 1. So I'm going to go with a positive 1 and a negative 2. And that's what I'm going to fill in each bracket. First bracket will become x plus 1. Second bracket is x minus 2. And the denominator is x plus 1. At this point, you guys will notice that this bracket in the numerator is exactly the same as the denominator, so they can cancel out with each other. And what we are left with is x minus 2 as our final answer. So now, 1.4.3 is testing you on your knowledge of exponents. So I know this question looks a bit daunting at first. We have 3 to the power 500 times 7 to the power 500 times 2 to the power 502 all over 42 to the power 500. So for a question like this, the first thing we need to do is make sure that all of our bases are products of prime numbers. So in our numerator, 3, 7, and 2 are prime numbers, so that is fine. But this 42 in the denominator is not a prime number. So we're going to start off by using the ladder method to get that 42 to be a product of prime numbers. Now let's state the first few prime numbers. And using the ladder method, 42 divided by 2 is 21. 21 cannot be divided by 2 without a remainder, so we go on to the next number. 22 can be divided by 3, that would give you 7. And 7 can be divided by 7 to get 1. Remember, you guys, when you use the ladder method, your aim is to end up with 1 at the bottom. So we're going to keep this numerator as is, and where we have 42, we are now going to replace it with 2 times 3 times 7. And that existing exponent is going to go outside the bracket. In the next step, we want to get rid of this bracket. So I'm going to keep the numerator as is. And to get rid of this bracket, we are going to apply laws of exponents. Remember, this 2, 3, and 7 all have exponents of 1. So applying laws of exponents, we are going to multiply those exponents together. 1 times 500 is 500. So this becomes 2 to the power 500 times 3 to the power 500 times 7 to the power 500. And immediately you guys notice that there are some things in the numerator and denominator that are the same. They can cancel out with each other. The 3 to the power 500 from the top cancels out with 3 to the power 500 from the bottom. The same thing happens with the 7 to the power 500. Now, to simplify, I am now dividing bases that are the same. So I'm going to subtract the exponents, and it is going to be the top exponent minus the bottom exponent. This leaves me with 2 to the power 2, which is equal to 4. And that is our final answer. So that means that that initial fraction that was given to you simplifies and is equal to 4. So we're actually done with question 1. We can now go on to question 2. And okay, slight numbering mistake. This should be 2.1. So question 2.1 says, solve for x in each of the following equations. Starting off with 2.1.1, we are given x into 5 minus x is equal to 0. So you guys, a common mistake that I see with this type of question is that learners start multiplying things out. Remember, you are factorizing for x. So what they've actually done is they've given it to you in the factorized format. All you have to do is take each factor and equate it to 0. So we're going to start off by saying x is equal to 0 or 5 minus x is equal to 0. Now we've already got one answer here. Working with the next part, I'm going to keep the 5 on the left hand side and I'll take this negative x to the right. So here are my two values, x is equal to 0 or x is equal to 5. Going on to 2.1.2, on the left hand side we have x minus 2 and on the right we have 8 over x. Now you guys need to understand that you cannot solve for x if it's in the denominator. So we want to get rid of this denominator. And how we're going to get rid of it is we can take this x and multiply it across. So it's going to multiply with the left hand side to give us x squared minus 2x. And on the right hand side we are left with 8. We can now take this 8 over to the left, and when it goes over it's going to become negative 8 and we are left with 0 on the right. Now you guys will notice that this is in quadratic format. Actually, we can say that it is in standard quadratic format, since we've got the format of ax squared plus bx plus c is equal to 0. So that is actually what standard quadratic format means. Now we're going to focus on factorizing, and we are looking for factors of this third term, which is negative 8. First, focusing on 8, factors would be 1 and 8, 2 and 4. And remember, you are looking for factors that when you multiply them, they give you negative 8, and when you add them, they give you negative 2. So I'm going to go with 2 and 4, and I'm going to use this as a positive 2 and a negative 4. So to factorize, I'm going to open up two brackets. I'll have x and x. One bracket is going to be x plus 2. The other bracket is x minus 4. Now, once you have your brackets, all that you have to do is take each bracket and equate it to 0 separately. And that will allow you to solve for x. So in the first part, we're going to take that positive 2 over to the right. We're left with x is equal to negative 2. And in the second part, we're going to take that negative 4 over to the right. It becomes x is equal to positive 4. So those values would be the answers to these questions. Moving on to 2.1.3, we are given x to the power 4 is equal to 27x. Now the first thing you guys can do here is, you notice that you have x on both sides. So let's get rid of x on the right hand side by dividing both sides by x. On the right hand side, those x's are going to cancel out. And on the left, if we apply laws of exponents, we are left with x cubed. So we've got x cubed is equal to the square root of 27. Next step is for us to get rid of this cube, and the only way to do that here is to cube root. Please remember, it is an equation, so what you do on one side, you must do on the other side as well. On the left, the cube root and the cube cancel out, and you're left with x. On the right hand side, the cube root of 27 is 3. So 2.2 says 4 to the power x minus 3 times 2 to the power x plus 1 minus 27 over 2 to the power x plus 3. And they ask you to simplify. The first thing I need to point out with this question, you guys, is that there is an error. Okay, so this negative 27 is actually the wrong value. It should be negative 18. So everything else in the question will remain as is, but the negative 27 is supposed to be negative 18. So I'm going to work with it as that corrected way, where I've got the negative 18 at the end. Now, the first step for a question like this is to make sure that all of your bases that have x as the exponent, those bases need to be products of prime numbers. So I'm first going to start off by replacing 4 with 2 squared. And that existing exponent of x goes outside the bracket. Everything else will remain as is for now. Or actually, what I can do is, I notice that this 2 has 2 terms in its numerator, so I'm going to split it up as 2 to the power x and 2 to the power 1. And I'll keep everything else as is. In the next step, I want to get rid of this bracket, and I am going to apply this particular law of exponents that says that when we are raising a power to a further power, we multiply the 2. Another way of looking at this is that a bracket means multiplication, so we multiply those exponents together. So that is going to give me 2 to the power 2x. In my second term, I want you guys to notice what is being multiplied. I've got 3 times 2 to the power x times 2 to the power 1, which is 2. If I multiply the 3 and 2 together, I've got 6 times 2 to the power x. So that allowed me to simplify. I'm left with minus 18 and denominator as is. Remember, this 3 is being added on to that term. So the plus 3 is not in the numerator. Now there is something that you guys need to notice at this point, which may be a little difficult at first, but this numerator is actually a trinomial, and we're going to factorize it as if it is a quadratic trinomial. So to do that, I'm going to open up 2 brackets as I would for a trinomial. And I'm going to ask myself, what times itself is going to give me 2 to the power 2x? Now that is going to be 2 to the power x. And if that confuses you, then I just want to show you on the side here. 2 to the power x times 2 to the power x. You guys know, according to laws of exponents, when you are multiplying bases that are the same, you can add the exponents. So you see that this does give you 2 to the power 2x. I'm now going to look for factors of negative 18. When I multiply them, they must give me negative 18. And when I add them, they must give me negative 6. So exploring the factors of 18, it would be 1 and 18, 2 and 9, 3 and 6. Okay, one thing I do want to point out here, you guys, is that we are not going to get this negative 6. And the reason why we're not going to get that is because we actually should get negative 3. Why we should get negative 3 is because that is what it initially was. Remember, we had multiplied it and made it negative 6. So we're looking for factors that when we multiply will give us negative 18, but when we add them, it should give us negative 3. So just take note of questions like this where you multiply things out and it changes the middle value. So you have to go to your steps before you had multiplied to see what that middle term should actually be. Now, if we're working with this negative 3, then the factors I'm going to work with is 3 and 6, where I take it as a positive 3 and a negative 6. So my first bracket is going to get a plus 3 and my second bracket minus 6. So that matches this step, okay? Now, looking at my denominator, I've got 2 to the power x plus 3. And immediately, you guys will notice that this bracket is the same as the denominator. So they're going to cancel out with each other. And what we are left with is 2 to the power x plus 6 as our final answer. Let us now go on to 2.3, and we have an inequality. So in 2.3.1, we need to solve this inequality, and 2.3.2, we need to represent this on a number line. So here is what we're given, and the good thing is there is no error with this question like the previous one, so we're good to go here. Now your aim, you guys, is to get x alone in the center, meaning that whatever else you have in the middle, you want to get rid of it. So the first thing we're going to try to eliminate is this 1. And we're going to take that 1 over to both sides. When it goes over, it is going to change its sign, so it becomes a negative 1. Now on the left-hand side, we have minus 15 minus 1, which gives us negative 16. In the center, if we subtract 1, we are now left with negative 4x. And on the right-hand side, 5 minus 1 gives you 4. The next step towards getting x alone is to divide throughout by this coefficient, which is negative 4. And the first thing you guys need to take note of is that when you have inequalities and you are dividing by a negative, the sign changes. It's going to go from being less than to greater than. In the center, the negative 4's cancel out. We are left with x. On the left-hand side, negative 16 divided by negative 4 is positive 4. And on the right-hand side, 4 divided by negative 4 is negative 1. So that is going to be our final answer. And for 3.2.3, we're going to draw our number pattern based on this. So here's how we do it. We start off with the number line and represent these two values. Always put the smaller value on the left and the bigger value on the right. We're then going to draw two circles, so one above each value. If the question does not have, if the answer does not have equal to's in it, then these circles remain unshaded. If there was an equal to, we would shade the circle. And to understand this mathematically, this answer says that x lies between 4 and negative 1, meaning that we are representing all the values between 4 and negative 1. And to show that on this diagram, we are going to draw a horizontal line joining both circles together. So that would be it. We're now looking at 2.4, and it says solve for x and y simultaneously. So here's what we're given. And I'm going to start off by working with the first equation. In that first equation, I'm going to make x the subject of the formula by taking the 3y over to the right-hand side. When it goes over, it becomes negative 3y. So at the moment, it is as if we know what x is equal to. So we're going to take this value for x and substitute in the second equation where we have x. So we've got 2 into, and in place of x, we are going to write 12 minus 3y. Let's keep the rest of it as is, plus y is equal to 9. We're now going to take this 2 and multiply into the bracket to give us 24 minus 6y plus y is equal to 9. Gathering like terms, we've got negative 6y plus y, which is negative 5y. We're going to take this 24 over to the right. It is going to subtract to give you negative 15. We're now going to divide throughout by negative 5, and we are left with y is equal to 3. So we've managed to solve for y. And now that we know what y is, we're going to take that value and substitute into the previous equation. Doing so, here's what we get. X is equal to 12 minus 3 into 3. And remember, you're always substituting into a bracket. That is going to be 12 minus 9, which is 3. And that is your x value. So we have solved simultaneously, and simultaneously means at the same time. We've managed to solve for x and y at the same time. So that brings us to the end of question 2, and we are now ready to go on to question 3, which is based on trigonometry. So let's read. It says, in triangle PQR, QR is 4 centimeters, PR is 5 centimeters, and QP is 3 centimeters. PQ is perpendicular to QR. Angle P is theta, so we see that here's angle P, that's theta. Angle PRQ is alpha. So here is PRQ, which is alpha. Now, you guys will notice that you have all 3 lengths of your triangle given, which is good. That means that we are ready to answer the questions. Now, before I do that, I'd like to start off by labeling each side of the triangle. In terms of theta, the 4 centimeters, which is QR, that is opposite theta. So that is going to be our opposite side. That makes the 3 centimeters the adjacent side. And the 5 centimeters, which is PR, is opposite the 90 degrees. So that is going to be the hypotenuse. Okay, now we're ready to answer. So sine theta. Sine is always opposite over hypotenuse. So reading it off from this diagram, that is going to be 4 over 5. The next question is based on sec alpha. And before I even answer this, we need to take note that alpha is a different angle, meaning that the opposite and adjacent sides are not going to work for alpha. They worked for theta. So let's start off by renaming this triangle in terms of alpha. The side that is now opposite alpha is the 3 centimeters. So this is the opposite side of alpha. That makes the 4 centimeters the adjacent side, and the hypotenuse remains as is. So if we think about sec is the reciprocal of cos. So cos is normally adjacent over hypotenuse. Sec is going to be hypotenuse over adjacent. So in terms of alpha, hypotenuse is 5 and adjacent is 4. So that is going to be 5 over 4. We now need to get tan theta. So we're back to theta, and remember tan is opposite over adjacent. That is going to be 4 over 3. Now 3.2 requires you to calculate the size of theta. And here's how we're going to do this. We can either use our answer from 3.1.1 or 3.1.3, where we had values for sine theta and tan theta. I'm going to choose to go with sine theta. So we had sine theta is equal to 4 over 5. To get theta alone, we're going to take sine over to the right-hand side. But here's what happens. Whenever you take a trig ratio over the equal to, it gets a -1 exponent. So this becomes sine to the power -1. And in the bracket, we're going to fill in this fraction 4 over 5. Now, you guys are going to put that onto your calculator, and you should have 53.13 degrees rounded off to 2 decimal places. So that is theta, and that brings us to the end of this paper.